All right, now the next part of lesson 4 is solving systems of linear equations graphically. So we understood from the last video, hopefully, that when we solve a system of linear equations, we're trying to find the point in common to both lines. That's what's going to happen most of the time. There are occasions when we have parallel lines or the same line. Now, what this section does is basically say, well, the first step, the first way, the first method we may choose is to rely on the stuff we did back in lesson 2.1 and 2.2. And that's basically just graphing a line, graphing the other line, and then visually trying to see where those two lines intersect. Now, in this section, sometimes our graphs, or excuse me, our lines will be given to us in what's called standard form, ax plus by equals c. Other times we'll be given the slope-intercept form. We've dealt with this a lot, y equals mx plus b. Notice this b here and that b there are not the same b's. One of them's capital, one of them's lowercase. And so basically what we can do, no matter what form we start with, we can always change things into slope-intercept form and graph using the slope and the y-intercept. So that's what we're going to do. I'll show you how to do this on two examples here. The first example is the one that the book has as example 1. It says, let's take two lines, 2x minus y equals 6 and x plus 2y equals 8. And let's look at the system of linear equations made by these two lines. So you already see that the book has this graphed for you, but I'm going to go through how to do this. So 2x minus y equals 6, x plus 2y equals 8. What I like to do is I like to graph each one individually. So I'll take this 2x minus y equals 6, and I'll write that down and graph it. Now, in order to graph this, I like dealing with slope-intercept form. So that's what I'm going to do. It's in standard form right now. So I'm going to subtract 2x from both sides. If I do that, the 2x goes away from the left-hand side, and I get a minus 2x on the right-hand side. Then I have a coefficient of negative y. So what I would do is divide both sides by negative 1. If I divide the right-hand side by negative 1, I get 2x minus 6. So this line in standard form is this line in slope-intercept form. And then I would go and graph that line. All right, so here I have a graph. Remember what we're doing is graphing using the slope-intercept form of y equals 2x minus 6. So 0, negative 6 is the y-intercept. There it is. Let me actually draw that a little bit thicker. And then slope of 2, think 2 over 1. That means go up 2 over 1 to get to my next point, up 2 over 1 to get to my next point, up 2 over 1 to get to my next point. Now actually go ahead and draw the graph of the line and graph as much as you can, right? Don't just stop, don't draw a really little line because I don't actually know where it's going to intersect the other line yet. So the more points, the longer you graph this, the more likely, the longer you make your line, the more likely you are. I graphed that kind of off. The longer you are to find the point, the more likely you are to find the point of intersection. So y equals 2x minus 6 looks like that. Now let's go back to the other line. y equals 2x minus 6 was their first line. Our second line was this one, x plus 2y equals 8. So once again, I'm going to take that, x plus 2y equals 8, and I'm going to convert that into slope-intercept form. The way we do that is we subtract x from both sides, subtract x from the left, you just end up with 2y on the left. Subtract x on the right, you get minus x plus 8. Then you can divide both sides by that 2. If I divide the left-hand side by 2, I get y. If I divide the right-hand side by 2, this is negative 1x, so you get negative 1 over 2 times x plus 4, right? 8 divided by 2 is 4. So now I just have to graph y equals negative 1 half x plus 4. So go back to the graph. Again, it's helpful if you graph this on the same graph. All right. So 0, 4 is the y-intercept. There it is there. Negative 1 half means go down 1 over 2, down 1 over 2, down 1 over 2. And you can see the pattern we get. My line's right there. Ooh, I didn't draw that real straight. But we see about where it's at here. It looks like it crosses at the point 1, 2, 3, 4, up 2. So it looks like it crosses at the point 4, 2. So we would say our solution to that system of linear equations is the point 4, 2. Okay? And that's what you would write as your answer. Now you see some of the downfalls already of graphing these lines and finding the solution using graphs. If I don't draw my lines really straight, sometimes if I drew this more off than what it is, it might be hard to tell where they actually cross. The other downfall is if my point of intersection is over here, like off the grid, then it's really hard to decide, what point that is. So those are the two main downfalls. The other downfall is, if my point comes in at about right there, if it has fractions in it, it's kind of hard to understand where that fraction happens to be. But it is a good way of doing things. It's good as long as our x and y are whole numbers, and again, not off the charts. So let's do one more like that. I'm going to do the one in 2-4B cooperative group problems. Solve the system of linear equations graphically. I'm just going to give you the very really quick idea of how to do that. So I'm not going to actually go through every step this time, but just tell you what's going on. So first off, 3x minus y equals 5, and x plus 2y equals 4. So 3x minus y equals 5. When I take that, I can convert that. Let's highlight this in maybe dark blue, I guess. I can convert that into slope-intercept form by subtracting 3x from both sides and then divided by a negative 1. If you do that, you're going to get this. You're going to end up with y equals 3x minus 5. All right, so y equals 3x minus 5 comes from this one when I put it in slope-intercept form. I can do the same thing with x plus 2y equals 4, that I'm highlighting with my cursor. Well, I can convert that and put it as y equals negative 1 half x plus 2. So when I solve that, y equals negative 1 half x plus 2, I say solve, meaning put it in slope-intercept form. So the graphs of those lines are going to be these two. Now I've already graphed those two lines. I'll go through real quick, do it again. Y equals 3x minus 5. So we're going to start here at 0, -5, and then go up 3 over 1, up 3 over 1, up 3 over 1, and then draw the line. So this blue line is the y equals 3x minus 5 line. Now, as far as y equals -1/2 x plus 2, -1/2 x plus 2, we start at 0, 2. -1/2 means I go down 1 over 2, down 1 over 2, down 1 over 2. So now I can graph this line. This red line here, the one I'm highlighting, is y equals -1/2 x plus 2. And if you look at this, where do these two intersect? Where do these two cross? They look like they cross right here. Oops. Maybe I'll go a little bit thicker. There we go. They cross right here. And you can see that that point is the point 2, 1. So the solution to this system of linear equations is the point 2, 1. All right? Now, this graphing method is not the most efficient method because things that I've said before, like what happens if a point is off this chart, what happens if I draw a squiggly line. Notice, down here I kind of screwed up and drew my line pretty squiggly. Over here I drew it pretty squiggly. So if I don't have a steady hand, sometimes that can throw me off. If the point goes off the charts, sometimes that can throw me off. And if I get fractions, especially hard ones to see, that can throw me off. So we're going to, in the next two videos, we're going to look at two other methods to finding the point of intersection of two lines. Those are called addition and substitution, or elimination and substitution.